Hello, everyone. We have Kevin Ko with us, and he would be presenting on an intro to workflow management with Prefect. And the session is going to be for 30 minutes, including Q&A. And please note that the whole session is governed under PyData Global Code of Conduct. And please adhere to the code of conduct and don't violate it. So, not taking much of your time, Kevin, over to you. And if you could just start with a short bio of yourself, that would be wonderful.
Yeah, I have my bio in my slides, so I'll start sharing my screen first.
Awesome.
So hey everyone, welcome to an intro to workflow orchestration. I can answer questions during the presentation since this builds on top as we go along. So you can just feel free to throw them in the chat. I'll pay attention to the chat. Yeah, with that, so welcome to this session. A bit about myself. I am an open source community engineer at Prefect. Before that, I was a data scientist for 4 years. Outside the work, I contribute to Fugue, an open source project for distributed compute, which is actually the other concurrent session. And then I also run the Orlando Machine Learning Meetup. Today what we're going to do is we're going to cover what workflow orchestration is, and then we'll go over a simple problem and how you would apply Prefect to orchestrate your workflows. And then we don't have a lot of time today. We'll briefly overgo Prefect and Dask together, and then we'll discuss the future of Prefect. We've had major updates this month that we'll go over. So with that, let's start with workflow orchestration. So if you're not familiar with workflow orchestration, in general, you have a data pipeline, whether it's an ETL job, or maybe it's some kind of machine learning job where data is going around and there's like interconnected components. So here we have a database, maybe we're getting a file from that database, we're hitting some API for additional information, putting them together in a pandas data frame. And then we train a model, persist some artifacts, spin up a server with that machine learning model. If you're not as familiar with machine learning, this in general, you'll have a diagram like this for your ETL. And in such a diagram or in such a pipeline, you have a lot of these interconnected components, right? So what happens if this API intermittently goes down, or what happens if this database actually dies and this thing cannot run? What happens if our model doesn't train right? Maybe the metrics don't look right, or maybe the model didn't converge or ran out of memory. There could be a lot of reasons why these things fail, right? And they're very interconnected. So if we look at the points of failure, like your database going down, your API going down, like even this API call to MLflow where you persist an artifact, there's just a lot of different reasons that are, and a lot of them are beyond your control also, like these APIs intermittently failing, compute going down. These are stuff that are out of your control sometimes, and sometimes these failures just happen. And when they do, it's quite a lot of work to one, work around it, but two, even if you were to try to prevent it, it takes a lot of work to code against these having code that can handle these failure paths correctly. And as pipelines get more and more interconnected, what we have here is a BI pipeline maybe that shares some common component with a machine learning pipeline. Now we have these interconnected pipelines that have multiple ways that they can fail. And if they fail, we want them to only affect their pipeline and not necessarily other pipelines. And we want them to also be, we want the failure logic to be handled very gracefully. Like maybe we can reuse like old data instead of fetching if pulling new data wasn't available. Maybe in some cases like the API, maybe it's just a simple retry, right? And all of this is what we call negative engineering. So negative engineering is all those things that you do in order to get your data pipelines running smoothly. So if your code worked 100% of the time, then you would not need any sort of negative engineering. But in reality, we need a lot of negative engineering. We need a lot of failure handling. We need maybe timeouts, notifications when stuff goes down. We need ways to handle malformed data or APIs going down intermittently, like in the form of retries. And Prefect was created because you often hear like developers spend like 90% of their time on negative engineering, or even 80% of their time. So in Prefect, if it's 90% and we can reduce that to 80% or 70%, then in effect we can double or triple developer productivity. So Prefect's mission is to eliminate negative engineering. And a bit about Prefect, the company. So there's the company. Prefect is both the company and the open source project. So the open source project right now has 7,700 plus GitHub stars. We have a Slack channel, which I personally manage. It's like my job to answer Slack questions and support our community. We have around 10,000 users right now in that Slack community. So Prefect is an open source workflow orchestration framework that's Python based, specifically designed for the modern data stack, right? So it's meant to really handle the volumes of data we're seeing today. And one of the ways it does that is a native Dask integration. So it can scale to big data seamlessly. We have a very active community. There's a lot of people, a lot of data engineers, a lot of people doing very cool stuff. So even if you just want to chat about data engineering or workflow orchestration, or you're thinking of using Prefect and you just have a couple questions you want to ask, like by all means, just join our community and you'll definitely get a response. And then Prefect has two components. One is what we call Prefect Core, which is the API with which you design your workflows, which we'll see today. And Core runs with a backend. So this backend is, if you use our managed version, that's called Prefect Cloud. And if you go and spin up the open source version on your own infrastructure, that's called Prefect Server. So you can fully do that. But we'll also show you why using Prefect Cloud, because of the model of which we run things, all the running happens in your infrastructure as opposed to our server. And this is a sample of the UI that you see when you go to Prefect Cloud. So this is my dashboard. Red is the failed flow runs. Gray will be the canceled flow runs. Green will be the successful flow runs. And a lot of our users kind of describe Prefect as their single pane of glass where they can see all of their flows, and if there's anything wrong with them. This is fully interactive. You can click into these red bars, see the specific error logs, the tasks that failed. Similarly, you can also click into the green runs just to see everything ran as expected. We even have people who have been requesting Prefect on mobile, because we do have users that have said that they check their phone every day in the morning just to see if there were any pipelines that didn't run successfully. So this specific month has been pretty big for Prefect, the company. We made 2 announcements earlier in the month, and this is the first conference where we're talking about it. So number one is we acquired a data consulting firm called Slate Data based in Chicago. And this acquisition allows us to provide better enterprise support. But also really big is this announcement of Prefect Orion. So Orion is what Prefect right now is in version 0.15. Orion will basically be our 2.0. And Orion has a lot of breaking changes based on of the previous 3 years that where Prefect supported people and their workflows, and realized that there were a lot of fundamental things that if we could work around, then we could provide a much smoother developer experience for building workflows. And so I'll also show Orion later on. Right now, Orion is in technical preview, so you can go spin it up, try it out yourself. It's open source as well, and it is pretty different from any other orchestration framework out there, and I'll explain that later. So first, we're going to see the current Prefect core. So now we have this Orion, and we have current Prefect core. The one for production workflows today, you would still use Prefect core, as Orion is still in technical preview. And Prefect core, I mentioned, is in version 0.15. We're steadily going to make that a 1.0 pretty soon after we stabilize it just a bit. But I mean, it is very stable. It is used by a lot of companies in production workflows already. So for our motivation today, what we want to do is we want to track Dogecoin prices, and we just want to be alerted when there's a dip in Dogecoin price. And when I first prepared this talk in the Dask for the Dask Summit earlier in May, there was this major dip in crypto. Everything just down 10%. It was quite shocking. I mean, I don't trade crypto myself. I don't know if we have anyone out there who does, but yeah, in general, we're interested in capturing these like dips so that we could get an alert. So first, we're gonna do this in pure native Python without Prefect, right? And we have two functions. So there's gonna be 4 steps. Number 1, we're gonna make a URL. Number 2, just a simple request for that to get the data. Number 3, the actual check for dips. And then lastly, we're gonna send ourselves a Slack notification only if there is a dip. So here we have the first function. The only thing you really need to know is we're hitting the CoinDesk API, and we are passing in a coin. And this coin will be plugged into the URL so that, and we'll just return this URL. And then this get data function, we're just gonna do a get request to that API, and then we're gonna get the a data frame of the results and pass out that data frame. And then we have our detect dip function. So we just get our data frame, get the peak, get the bottom. There will be the data changes every minute. So we will just be getting 10 minutes of data. So just like a 10-minute window, 10 measurements. And we'll just check the max of that, the min of that, see if there was like a major percent, dip. If there was, we'll return true. If there wasn't, we'll return false. There's a threshold here. So this is like 10% dip that we're expecting. And if you're to put this in production, what you would do is something like, create an EC2 instance, make an infinite loop to be run every 5 minutes. We're gonna get our data, check if there's a dip, and if there's a dip, we'll post to Slack. So I didn't implement the post to Slack yet because it's gonna be a lot easier in Prefect, and I'll show how later. But in general, we have this up and running. And again, with negative engineering, there's many things that can go wrong, right? So like what happens if the API fails, hitting the CoinDesk API? Well, maybe we could code retries ourselves, right? Or what happens if we wanted to track another coin instead of Dogecoin? Well, I'd have to spin up another process, change Doge there, and then run that separate process. What happens if we wanted off-schedule runs besides this 3, like we wanted a run now, right? Instead of this 300 seconds, well, I'd have to go to that box, take out this while loop, run another script, right? So there's all of these are certainly things that you can work around, but the more and more you do it, the more you're gonna find that you're actually writing more code to handle that failure, because our core code here is not long at all, right? And more of the work will actually be done to handle failure. And that's where we can bring this to Prefect to show how we can make this, how Prefect can handle these for you. So the first one is the workflow orchestration semantics of Prefect. So Prefect, we have tasks and we have flows. Flows are comprised of tasks. So you can think of tasks as just like a Python function, and flows are a group of tasks, right? So basically more like a Python script. And in order to bring this to Prefect, all we have to do is decorate this with a task decorator. And now this is something that can be brought into Prefect. And then a while ago, we had our loop. So now we just change it to this flow object and we say with flow as flow. And we have all these tasks that are called. And then we can do flow.run to execute it. And there's 3 important things here. Number 1 is that if you look at this, there is a first class support for passing of data. So data will become a data frame. We pass data to this detect dip. So we can pass data in memory from task to task. And this is a very Pythonic syntax. This is still the original code. We didn't really change it, right? We just wrapped our task decorator around it. Number 2 is that there's an automatic setting of dependencies. So when you pass data to this detect dip task, detect dip will realize that get data is an upstream task. And so Prefect will create the DAG of the execution DAG for you. And the last thing is local testing. So if you do flow.run, it's just like running a Python script, you get your output. And a lot of other orchestration frameworks, they'll require you to spin up certain infrastructure, whether that be like Kubernetes, whether they're tied to Kubernetes, or whether you have to spin up the server, the database, etc., just to test your flow. In Prefect, it's very seamless. You just do flow.run and you run your flow like a Python script with the additional logging that Prefect provides. And then we have an API call here, if you remember. What happens if this goes down? Because APIs can just, occasionally return, occasionally fail. So in Prefect, all we have to do is add the max retries and a retry delay. So this will try up to 3 times. This whole task will try up to 3 times with a 1 minute delay between each retry. And now we get retries on this task. The next thing is what happens if we wanted to track some other coin. Well, remember that my get data task took in the Doge parameter here. Now I can parameterize my flow on the flow level, and my task logic doesn't have to change by making this parameter called coin, and then I could just do get data of this coin parameter that comes in. So during runtime, we can plug in, Bitcoin or Ethereum instead of this Dogecoin, and the whole flow would run for that specific parameter. So what parameters is also one of the strengths of Prefect. It's a very intuitive interface. It's just like Python, basically. There's no Jinja templating or anything like that. And here we can experiment. We can also do flow.run with with different parameter values. So here I just do flow.run with the Bitcoin, and now this whole flow logic will run with that. The last thing I said is that we want to post to Slack. I told you that this would be a lot easier in Prefect, and that's because we have the task library in Prefect. So you saw what tasks look like, and because they're just Python code, what we can do is we can make a library of just these API calls. Like for example, the database calls are pretty straightforward. Normally, you're just passing in a query into the task, and then you get some data out. So MySQL, PostgreSQL, like we have these tasks written for them so that you can easily just do that. Like Databricks submit job, maybe you want to upload to S3. So we even have people who are not as familiar with Python, but through the task library, they're able to construct flow like ETL flows because a lot of the standard connectors that they need are already present here. Specifically today, I'll be using the Slack task in order to send myself an alert. So I'm going to import the Slack task and I'm going to provide this message. There was a dip in Doge price. And I provide this webhook secret. So the webhook secret is a secret that I store on Prefect Cloud that's fetched during runtime that contains a link to the Slack channel that I want to send my message to. And then we can just post this to Slack. We can call our post to Slack task, which is this one that has already been configured. So yes, the secret is just this. This is the name of my secret. We're going to pull it during runtime and execute the task with that secret. So a while ago, we had this conditional logic. This red highlighted code above is our previous non-prefect code. We did this if there is a dip, post to Slack. In Prefect, we have our own if-else task called case. So if with case, if the dip is if dip is equal to true, then we'll just post to Slack. Now we know that all our logic is complete, we just need to register this to Prefect Cloud. So we provide flow.register and a project name. And the project name is just like for the UI, there's some separation that flows belong to certain projects. So we're just providing a project name to attach it to a project. And as we register, the last thing that's important is a schedule. So schedules, we just want to run this flow at a given schedule. So we can construct it for us. We just want this every 5 minutes. So we'll do an interval clock every 5 minutes with Doge as the default parameter. And then we create a schedule and attach the schedule to the flow. And now when we register this schedule will be applied. And with that, we're going to do a quick demo over here. So I have my Prefect Cloud UI, and it's going to load. So there's a question here in the chat. In the Doge example, why do you need with case instead of using a regular if? Yeah, I understand. So here the question is over here. Why do we need the case? And that's because if you use the Python if, it's not a task, and you need you need to use a task for it to have deferred execution to bring this logic into runtime, right? So in order to do that, we need to implement our own task that it gives that if-else behavior. But with Prefect 2.0, you can use the Python primitives, you can use the Python if, else, you can use the Python controls, and it's very, very like the development experience is even more like it's just like writing Python code. So over here, what I'm gonna do is I'm gonna go to the PyData. Actually, my internet cut off earlier. I'm gonna refresh this. So I'm in my PyData project, and I have my flow here that we just worked through together, and I registered it with this flow register PyData. So I attach it to the PyData project. And now what we have to do is we have to start an agent, and this agent lives on your infrastructure, pulls Prefect Cloud every 10 seconds. Hey, is there a flow to run? And if there's a flow to run, it pulls that flow down, or not really down. It's more like it finds where that flow is stored. We don't store it for you. And then it pulls it, and then it executes it on your agent. So all the execution lives on your infrastructure. And this is one of the biggest reasons why people use Prefect. So over here, in our PyData project, we have this flow registered. And I'm just gonna give it a quick run. Oh, I'll go to flows. It's this to the moon flow over here. And now I'm just gonna hit this quick run button. And you should see there's gonna be a yellow bar. The yellow bar is like, there's a run that's being created, it's scheduled now. And then soon enough, it'll turn blue. Blue is running, so our agent picked it up. And then our agent deployed it, ran it locally. Green means it was a success. And last, you should see that because we had the Slack task, I have a alert here that there has been a dip in Doge price. I set the threshold very low for that to happen. So we're nearly out of time. So what I'm gonna do is I'm gonna not show the Dask stuff, but we do have like a native Dask integration also that allows for parallel execution. Instead, I'm gonna show what Prefect 2.0 will look like. And 2.0, we have this flow decorator. So this was created to be more, number one, there's a separation of build time. And in current Prefect, you have to build a DAG, and then during runtime, we'll execute that DAG. But in Orion 2.0, there will be no DAG, no pre-registration, because in a lot of ways, the DAG was confining people to have very static workflows. And now we're going to transition to having as much dynamicism as possible. And part of that is, as you mentioned, Mark Andre, where why can't I just use the Python if? Here we have the Python for loop that we can just loop through and then execute this task, right? And we want to provide like a very Python friendly developer experience. And I'm nearly out of time, so I just have a couple links here in my slides that I will be sharing. Definitely check out the Orion release and our press release around it. If you sign up for Prefect Cloud, you get free 10,000 free task runs every month. It's way more than enough to get started with. We have a lot of hobbyists who just use the free tier and run their workflows that way. Also, feel free to join the Prefect Slack. We definitely we will. If you have any questions, we'll get to you. We'll respond to you. And with that, I think I'm done and I can take questions. I have 2 questions here. Number one is Prefect like task scheduling like Celery plus monitoring? So think of it this way. Airflow, there's Airflow, right? And Prefect is like a next generation of like that kind of scheduler. So Airflow can use Celery as a task queue to do stuff in parallel. Prefect uses Dask, right? So Dask would be our equivalent task queue, and we would provide the observability around each of those tasks that run on top of Dask. So Celery is more like a distributed task queue, whereas Prefect is more like a batch level orchestrator. But the batch level orchestrator can live on top of like this like task queue. Number two, how will the transition to Orion from Prefect work? So the transition, we do have a lot of people on current Prefect. Current Prefect is not going anywhere anytime soon. It's gonna, be until like end of 2022 at least. And then transitioning to Orion, we will be producing a lot of like migration content for that. And it should not take long. Like it should only take like 2 to 3 hours to transition like from Prefect, like for a real project, to transition from like current Prefect to Orion, because a lot of the stuff is still there. It's just the engine and internals that have changed. Yeah, there's another question by Tom. What does the upgrade path look like for folks who have current Prefect to like Orion? That's same thing as I just mentioned. It shouldn't take too long. There's a lot of similarities. It's the internals that have changed and have become more flexible. In a lot of ways, it will also enable a lot of people to do stuff that they were struggling to do before with dynamicism. I have a question from Tin. How can I use Prefect for my AWS data lake pipelines? Yes, you can. And we have built-in tasks for that. So you can just like fetch your AWS data in some way, and then you can persist it. Or I don't like if you get it from a database, you persist it in the data lake after some transformation. That's something you can run on a schedule. Put that, let Prefect manage that for you, for sure. Florian said, big fan of Prefect. Oh, of course. I mean, Florian is a member of our Slack community. Looks like it will solve many pains we face for production code. Yeah. All right. Thank you. Thank you for the kind words, Florian.
All right. Thank you, Kevin. This was a wonderful talk, and I think we are almost at the time. So thank you, Kevin, for joining us today, and it was wonderful to have you.
Yeah. Thank you for having me. I'll see you.